Hi everyone, in this lesson I'm going to be explaining the binary number system. And to start, we're going to look at the decimal number system. And of course that's a number system based on the number 10. And it's the numbers that we use in everyday life. And they're based on 10 digits from 0 to 9. And historically chosen because our hands have 10 fingers. So we have an example here of the number that you're used to seeing. This place right here is a 10th decimal place. This is a 1 decimal place, 1/10th, 100th, 1,000th, and so forth. Now, if we look at the binary number system, that's a number system that's based on two numbers, the numbers 0 and 1. A bit is a binary digit, a single basic unit of information used in connection with computers. A byte just means we have adjacent bits. We usually have 8 processed by a computer as a unit. And binary is defined as a system of numerical notation to the base of 2. So here are the placeholders for binary. 2 to the 0. Well, anything to the 0 power is 1, except for 0. 0 to the 0 power is undefined. 2 to the first, 2 to the second, 2 to the third, and so on. So let's look at an example. If we were to look at the number 89 in binary, right, this would be the binary number for the number 89. And why is that? All right, so first of all, we would have to figure out for all these placeholders, we have 2 raised to a power. We have to figure out how we would be able to, add those together to get the number 89. So if you look at 2 to the 6, we would put a 1 there. That means that we would turn that switch on. We would have a 1 in that placeholder, so we would know that we were going to use 64. We wouldn't be using the number 32, so a 0 would be off. Now we're going to add 16 and 8. 16 and 8, right? So those are both on. And then we're going to turn off this placeholder, and then at that point, we only have 88, and we would turn on this last one to add 1 more, and that would give us the number 89. So in binary code, the number 89 is represented by either 1s or 0s, and this is the order in which we would demonstrate that number. Typically, they're in 8 digits. So if we wanted to, we could just put a 0 here just to represent that in terms of 8 binary numbers. All right, so let's do one together. All right, we have here, I'm going to do 1, 1, 1, 0, 0, 0, 1, 1. All right, and so what does that mean? That means that we're going to add 128. And 64 and 32 and 2 and 1. And when we add those up, we're going to get 227. So this binary number converts to the decimal number 227. Now, what I would suggest is right here, pause the video and try to do B and C on your own. And when you're ready, come back to the video. Okay, for this number, I'm going to write out just set up my binary number here. All right, anything that has a 1 means it's turned on, and I'm going to use that number. So I have 128 plus 64 plus 8 plus 4 plus 1. And when I add those numbers together, I'm going to get 205. All right, letter C. Line up our binary code. All right, so that means 128 is turned on, Number 8 is turned on. And that's all that's on for that particular one. That gives us 136. All right, now what we're going to do is convert from decimal to binary. So we want to figure out what 8-digit binary number would we need in order to represent the decimal number 64. Well, this one isn't that hard because you can see that 2 to the 6th power, this guy right here, is 64. So we know we need that one turned on, and everything else is going to be turned off. So this binary digit is going to be 0, 1, and then we have 6 zeros after it. All right, I would suggest that you try letters B and C on your own. Pause the video, and when you're ready, come back and check your answers. For the numbers 123, I'm going to turn on this bit, this bit, this bit, and this bit. This one will be off, this one will be off, on. So let's see, double check ourselves here. 64 plus 32 plus 16 plus 8 plus 2 plus 1 gives us 123. Just double check ourselves. So the binary digit for 123 is 0, 1, 1, 1, 1, 0, 1, 1. Let's try another one. I'm going to turn the first 4 numbers here on. I'm going to turn 8 off, 4 on, 2 on, and 1 off. Let's double check ourselves. We get 246. So this binary number is going to be 4 ones, a 0, 2 ones, and a 0. All right, so that's, really the basics of understanding binary and how it converts. So let's do something a little bit more fun, a little bit more realistic. We're going to convert some binary code to a message. Each binary number below corresponds to a letter in the table, and you have a table below here. What do you think the following message says? Now, there's a note here. These first 3 digits, the numbers before the red line, generally don't matter because they're going to denote either uppercase or other characters. So we're just going to focus on the numbers that are to the right of that line. So we're just going to basically ignore these first 3 digits. And so I gave you the first one. If you were to look up the value of the first binary number, we have 3 zeros, a 1, and a 0. Okay, so that means that the number 8 is turned on. All right, 8. This guy right here, and we're going to go down and find number 8, and 8 equates to letter H. And so the first letter in our message is H. All right, let's do another one. So the next one is, so we have 0, 0, 1, 0, 1. That means we have 4 plus 1, that gives us the number 5. If I look in my table, number 5 is associated with letter E. All right, so I would pause the video and see if you can decode the message, the rest of the message yourself. Okay, the next number is going to be 8 plus 4. 8 plus 4 is 12. If we look in our table, the value, the letter that goes with number 12 is L. We have the same number again, 12. That's going to be letter L. 1 plus 2 plus 4 plus 8. That's going to give us the number 15. If you look in our table, the number 15 goes with letter O. All right, so far we know we have hello, and we have a space. All right, the next number we have is 10100. So 16 plus 4, that gives us the number 20. If we look in our table, the number 20 is associated with the letter T. The next number we have is 0, 1, and all zeros. And that's the number 8. 8's associated with letter H. Number we have is 0, 0, 1, 0, 1. So that's going to be 4 plus 1. That's going to give us number 5. 5 in the table goes with letter 8. The next number we have is 1, 0, 0, 1, 0. So that's going to be 16 plus 2. That's going to give us the number 18. 18 is associated with letter R. And then we have the next number, the final number here, 0, 0, 1, 0, 1. So that's going to go with the number 5, and we know that's letter E. So this little message says, hello there. All right, that was kind of fun. That is the end of my lesson for today. You're going to decode another binary message in your practice. So I hope you enjoyed it. I hope you enjoyed this quick little lesson, this little introduction into binary code. Have a great day, and thanks for watching.